Hi class, my name's Cindy. Today we're going to be doing the burning magnesium experiment. So the first thing you're going to need are safety goggles and your lab coat. Also, if you're a girl, tie your hair up like me so you don't want to get it all burnt. We're also going to need a Bunsen burner, which looks like this. And the Bunsen burner is going to be connected to the gas valve here. Now, as you can tell, it's connected by a piece of rubber tubing. So first you want to check that the tubing has no cracks in it or no slits, as this could leak gas everywhere and that would be bad. You're also going to need a flint, which looks like this, and it's basically a spark, and this is to use to light the Bunsen burner. We're also going to be using tongs, which is to grab the magnesium. Magnesium looks like this, and it comes in the shape of a ribbon, so we're just going to be taking a little bit of that. Okay. So here's the magnesium ribbon that the teacher will have prepared for you. It looks like this, just a small little piece of magnesium. Okay, so here are some rules to lighting the Bunsen burner. After making sure that the rubber tubing is safe, you want to take note of the gas valve here. That allows the amount of gas that goes through the Bunsen burner. There's also the oxygen tube here, which if you screw or unscrew it, allows the amount of oxygen being allowed into the tube. Okay, so right now we're going to light the Bunsen burner and see what happens to the burning piece of magnesium ribbon. So in order to light the Bunsen burner, we're going to turn the gas valve on first and follow the 30-second rule. If you cannot light the Bunsen burner in 30 seconds, turn the gas valve off. That's a bright flame, okay. So we want to try to get a blue flame, and we're just going to adjust the valves. Okay, so as you can see, there's a blue flame. This means that the flame is hot enough for us to put the magnesium ribbon in. So here's the magnesium ribbon. It looks like this. It's just a piece of ribbon. We're going to pick it up with our tongs, and we're going to put it over the hottest part of the flame. Be careful not to stare at it too intensely because this may hurt your eyes. So here goes. And record the reaction in your lab reports. I can't see. Hi guys, my name is Cindy. Today we're going to be doing the candle burning experiment. So for this experiment, we're going to need ingredients such as these matches, which comes in a matchbox like this, and also a candle, which is made of wax, and the formula for wax is C25H52. So to begin this experiment, we're going to need to get a match and light the candle. Let's hope this turns out okay. My candle doesn't like to light up. Anytime now. It is burning up. Okay. Let's try that again. And it works! Okay. So I'd like you guys to observe the reaction of the burning candle. What do you think is happening? Notice also the oxygen reacting with the wax in the candle to create this flame. Hi class, my name is Cindy. Today we're going to be conducting the burning methane experiment. So the things you're going to need are this beaker, just a regular glass beaker, a flint, also a stand, which with a piece of mesh on top of it, and a Bunsen burner connected to a gas valve with rubber tubing. So the first thing you need to do is to make sure that your rubber tubing is free of cracks and free of cuts, so you don't want the gas to go everywhere. First off, we're going to fill in this beaker full of water. So I'll be back with water. So we just have tap water like so. So we're going to light the Bunsen burner while putting the water on top of the stand. Watch the reaction of the water and the burning of the Bunsen burner. You want to make sure you get a blue flame, so watch the reaction with the water. Be sure to record your observations in your lab report. Hello class, my name is Danielle, and we're going to observe the electrolysis of water using this handy dandy apparatus right here. Now the water should already be in here, it's just simple water. And we're just going to turn this on and observe the bubbles. We are collecting the gas into these two tubes right here. And note the two different volumes of the gases. Record your observations into your lab. Remember to turn this off.
Oh, hi class. I didn't see you there. My name is Mark, and today we're just going to be doing a little experiment known as the calcium and water station in your lab today. And first, we're going to start off by looking at our products, what we have for our station. But the most important rule we should really look at is safety, which is number one within all chemical experiments. So firstly, as you know, I have a lab coat on. It's for protecting my body from all the other chemicals. And secondly, I have my goggles, which are really important for protecting our eyes, as we will need them in this experiment. So, as I said before, our station is known as the calcium and water station. And today, I'll just be telling you what the ingredients are for using in our station, and I will show you how we're going to go through this experiment. So first, as you can see, I have a small beaker. Now this beaker is a regular beaker, it's glass, it's normal. Secondly, we have calcium metal. It is a regular metal found in your periodic table. Third, we have our tweezers. We will be using this for extracting a very important indicator. Fourth, we have our scoopula. Now, where we put our thumb here is where we will be extracting the calcium from our bottle and placing it into our beaker. And lastly, we have our red litmus paper. Now this is very important in class because I want you to note what actually red litmus paper does. So keep that in mind. So first we'll start off by filling the beaker with water. Here we are, just regular tap water, folks. Secondly, we'll be placing our calcium within the water and stirring it up a little to get it going. So here we are, my thumb on the scoop, right there. Here we are, class. This is how calcium looks like. So I'm placing it within the beaker, and I'm going to simply be using my tweezers and stirring it within the beaker. There we are. Now that the calcium is freshly diluted within the water, we're going to be placing our red litmus paper. So, because I hope you studied what red litmus paper was, because it's going to be very important in this experiment. So as you can see, I'll take my regular tweezers and extract the litmus paper. Here we are. This is red litmus paper, which I'll be placing within the beaker. There we go, and I'm just going to give it a little bit of a stir to see what happens. Now class, do you notice anything strange within the beaker? My red litmus paper that was once red is now blue. Look class, very interesting, oh my goodness. Now, if you've studied what litmus paper does, we know it's an indicator, and I hope you know what blue indicates. Thank you for watching this experiment. Oh, hi class. I didn't notice you there. I was just coming up from downstairs. So today I'm going to be doing a very important experiment. Now this experiment is highly dangerous, so I suggest you take extreme caution when performing this experiment. Today we'll be conducting and observing a reaction between a piece of mossy zinc and hydrochloric acid. Note kids, I said hydrochloric acid, which means it is extremely corrosive, and you do not want to get it on your hands, your clothes, or anywhere that can be damaged. Our second ingredient is pieces of mossy zinc. Very, very interesting. So what I will be doing is placing a piece of this mossy zinc within the beaker of hydrochloric acid, and we will observe and record our observations within our lab report. Let us begin. Take your piece of mossy zinc and place it within the beaker. Note the reaction happening. My class, do you notice something happening to the zinc within the beaker? Record this observation within your lab report. When you are done, remove the zinc from the beaker, place it back into the container, leave your hydrochloric acid, and clean up your station for the next student.
Hi class, my name is Danielle, and today I'm going to be conducting an experiment called the cupric sulfate and iron experiment. So for this lab, you will need your safety goggles. Girls, you will also need to tie up your hair so that you don't damage your hair. And we are also going to need a pair of tongs. We're going to need an iron nail, and your teacher will supply you with a beaker full of cupric sulfate. All right, so now we are going to take our tongs, we're going to get the nail and place it into the beaker of cupric sulfate. And we're going to leave it there for a few minutes and observe what happens. Okay, now we're going to take the tongs and remove the nail from the beaker. What do you notice about the color? Jot down your observations onto your lab. Make sure that you wipe the nail before the next person does their lab. And leave the cupric sulfate solution. Hello class. Today we're going to be observing the reaction between calcium chloride and potassium carbonate. Make sure that you have your goggles on, and girls or guys, make sure that you tie your hair up. So for this experiment we're going to need 2 clean test tubes, or else they will contaminate your experiment. We're also going to need 2 eyedroppers, and your teacher will provide you with a beaker full of potassium carbonate and a beaker full of calcium chloride. Alright, so first we're going to take 1 eyedropper full of calcium chloride and add it to a test tube. And then we're going to take 1 eyedropper full of potassium carbonate and add it to the other test tube. Now we're going to mix or pour 1 test tube into the other test tube and observe the reaction. Alright, so I'm just going to stir this a bit. Time is lost since we've added both aqueous solutions into the test tube. Notice what is formed. Record your observations into your lab. Why do you think this happened?
Hi class, my name is Mark. Shh, I snuck into the camera and I decided if I snuck in, why not do a lab? Well, today, as you can see, I did pick out a couple things before I left class, and I happened to pick out 2 test tubes, sodium hydroxide and ammonium nitrate. And this experiment is called the sodium hydroxide ammonium nitrate station experiment. So first what we'll need is our safety goggles. Number 1 rule in safety is to protect our eyes. Secondly, we will be pouring each solution into a separate test tube and then pouring them into the crucible. Firstly, I will take 1 eyedropper full of sodium hydroxide and pour it into 1 tube. Secondly, I will take another eyedropper full of ammonium nitrate and pour it into the other test tube. And then I will take both test tubes and combine them within the crucible. Just like this. When I'm done, I will take the crucible with my 2 solutions, and then I will take my hand and slowly waft the smell. Wow, what a very, very unique and different smell. What do you smell, class? Observe the recordings within your notebook.
Hey class, in this potassium chloride and this sodium nitrate lab, we're going to be demonstrating what will happen when you mix two aqueous solutions together. First off, we will need 2 test tubes, 2 eyedroppers, and a beaker full of potassium chloride and a beaker full of sodium nitrate. Before you get to this lab, you have to make sure that your glassware is clean and free of cracks, as it will contaminate the results. First off, you have to put a small amount of each aqueous solution into a test tube. And then you take one and then pour it into the other. Observe the reaction and record it in your textbook, in your lab report. Why is this reaction happening? Hi, my name is James, and today we're going to be doing the sodium hydroxide and the sulfuric acid experiment. When you come to this station, you have to make sure that you are wearing your safety goggles, as these two solutions are very corrosive. You will need test tubes, sulfuric acid, sodium hydroxide, and phenolphthalein. First off, take a test tube and put 2 eyedroppers full of sodium hydroxide into it. Next, you'll have to take some phenolphthalein, an indicator, into the sodium hydroxide. Notice the effects of the phenolphthalein. Then you take another tube, test tube, and take some sulfuric acid, 2 eyedropfuls of sulfuric acid, into a test tube. Then you take your phenolphthalein again and put it into the solution of sulfuric acid. Notice the effects of the phenolphthalein on the sulfuric acid. Next off, you will have to pour one of them into the other and record the results into your lab report. As you can see, it turns cloudy. Why does it do this? Hey class, my name is James, and today we're going to be mixing 2 aqueous solutions, one of cupric sulfate and one sodium hydroxide. First, you have to put 2 full test tubes of copper sulfate into one test tube. And then another 2 eyedrops into the other test tube. Next off, you have to pour one test tube into the other. Watch out, as these 2 chemicals are very corrosive. Notice the reaction. You should let it sit for a while for the reaction to happen. Feel what happens to the 2 chemicals, and record your observations in your lab report.
And it's really simple, actually. All you're going to need to do is light the candle and observe the reaction. shouldn't be doing this. It's burning up. It's burning up.
Oh, we've got some great like blooper footage, that's for sure.
My name is Cindy. Today we're going to be conducting the experiment of burning a match. A candle. I'm just gonna...
Burning a match and a candle.
Using a match to burn a candle.
Yeah.
What is it called? I can't do it. No, I'm not doing that.
So good.
That controls the gas. So opening it creates more gas to be. Start the thought again.
Want to do it from the beginning?
Be very unsafe. So we're gonna start. First thing you have to do is to turn on the gas valve. Oh, just that one again. I can totally do it without the Bunsen burner. Okay. Where should I start?
The gas valve.
So now we're going to turn the...
Okay. What the heck is that?
Okay, we'll let it keep going.
It's playing out so much better in my head.
It's like I'm hyperventilating.
Okay, I'll just walk into the frame then. That was lame.
Hello class, my name is Danielle, and today we're going to observe the Okay.
Always the last one.